All right, so for the number corner today, I will be modeling. So you need to ask yourself here, what is the missing number? What does n represent? So what divided by 72 will give you 9? So what times 9 will give you 72? 8 times 9 is 72. So the missing variable is 8. Okay? That's what that is. Okay? Missing number here is 8. Okay. And then here, this is the estimation question. Lisa used 84 beads on an art project Monday and 49 beads on Tuesday. About how many more beads did she use on Monday? So we're going to round to the nearest 10. 84 rounded to the nearest 10 is 80, which is below the midpoint. 84 is below the midpoint, which is 85. And then 49, we know that's closest to 50. It's only one away. And the question is about how many more beads did she use on Monday? So we have to subtract to compare. So 80 minus 50, the answer is 30. So Lisa used about 30 more beads on Monday. Here is a bar graph question, two-step problem here. The number of pizzas made in a week were recorded on this graph. On Friday, 2 less pizzas were made than twice the amount made on Tuesday. How many pizzas were made on Friday? So you need to look here, okay? And I'm going to bold this. Right here is what the information we're looking at. On Friday, 2 less pizzas were made than twice the amount made on Tuesday. Okay, let's bold that. Okay, so twice means 2. Okay, times 2. So on Friday, 2 less pizzas were made than twice the amount made on Tuesday. So we look at Tuesday and we see that 6 pizzas were made. Okay, 6 pizzas were made. And then it says on Friday, 2 less pizzas were made than twice the amount made on Tuesday. So twice the amount made on Tuesday would be 12. Okay, and 12 minus 2 is 10. So if we set this up right, 2 times 6, we do that first in the parentheses, because that's what it says. Twice the amount made on Tuesday. And then 2 less, that's going to be minus 2. And we can see now that 2 times 6 is 12. And 12 minus 2, the answer is going to be 10. Okay? So 10 pizzas were made on Friday. All right, let's look at the next slide here. We will be beginning to learn about elapsed time, the amount of time that has passed. Elapsed time is the amount of time that has passed. There are several strategies and tools that can be used to tell elapsed time. And there's a video here for you to watch. But to figure out elapsed time, we can use a T-chart. We can use something that's called Zoom. We can use a number line. And we can use something that's called mountains, hills, and rocks. And we will be talking about this. But here's a video for you to watch that will talk to you about elapsed time, that will give you more information. So you will need to watch this video. Okay, let's look at the last slide here. So before I do the last slide, I'm going to do an example of elapsed time. I'm just going to give you an example. So let's say the movie started at 10 o'clock and it ended at 2:30. How much time passed by? Okay, so it started at 10 o'clock. How much time passed by? Well, we could use a number line. to help us. Okay. And I don't have a number line here, but let's say the movie started at 10 o'clock. I'm just going to do it in a text box and do it like a number line. Movie started at 10 o'clock. So we know it started at 10 and it ended at 12. So we got 10 on one end. And I think I said it ended at 12:30. So that's on the other end over here. Okay. So let's just stretch that out. Okay. So it started at 10. Okay. So we know an hour from 10 to 11, that would be 1 hour. Okay. So we could put 11 here. Okay. Another hour would be 12 o'clock. Okay. So we can see that that's 2 hours. From 10 to 11 is 1. From 11 to 12, that's 2. Okay. And then from 12 to 12:30, that's 30 minutes. So 2 hours and 30 minutes is what that would be. Okay. 2 hours and 30 minutes. Trying to move that over. See if it'll go. It doesn't want to move. Let's see. Do not auto fit. Let's see now if it'll move. No, it's still not moving. There we go. All right, so let's go to this last slide here. These are word problems with measurement. Okay, let's look at this first one here. The pet store had 900 liters of aquarium-ready water in storage. If each fish tank took 100 liters and they needed to fill 6 tanks, how much water would be left over in storage? So we see here, and I'm going to put a text box around this so I can draw what I need here. Okay, so we see here, if it's going to let me here, let's see, I'll put a text box in here. There are 6 tanks right here. If each fish tank took 100 liters and they needed to fill 6 tanks, so that would be 6 times 100, which would be 600. Okay, I'm trying to make a text box right here. Let's see, I'll use a highlighter. Okay, let's see if we can put the text box here. Okay. All right. And I'm just highlighting the information that we were using here. Let's move this over. Okay. So it wants to do the whole thing. I don't want it to do the whole thing. Let's see. Kind of hard to do here. Okay, but I just want to highlight those numbers here. So we got 100. Okay, do not auto fit. So let's move that up. We got 100 liters and there's 6 tanks. Okay, so let's copy that box here. Okay, we got 6 there, 100 there, 6 here. All right, and let's do this. Let's make it red and bold it. Make it stand out so we can see it. All right, and then we got 6 here. We won't make that line as thick. Okay, so we got 100 times 6, that's 600. But they said that we had 900 liters. So we need to draw a box here. Okay. Let's move this over here and let's highlight that 900. Okay. And do not auto fit so that we can move the box up. Okay, and we will draw a red line around that number as well. All right, so now we can set up a problem. We got 900. Let's see, where did my text box go? All right, get another text box. So we have 900 minus 100 times 6, okay, which would be 900 minus 600. And how much water would be left over? We would have 300 liters. 300 liters. And L is indicated for liters. Capital L, liters. Okay. Let's do the next one here. Liquid measurement. Estimate the capacity. How much the container holds its capacity. Is it less than a liter or more than a liter? Okay, we learned yesterday that a liter is about the size of a Gatorade jug. Not the big jug, but the smaller size. So this is like a Capri Sun. That's going to be less than a liter. Okay, that's what that is going to be, less than a liter. So that would be A. Okay. And then this one, which measurement is the best estimate? How much soda would a soda can hold? Okay. That would be 355 milliliters. Okay, remember milliliters are smaller than liters. Okay, that soda can will hold milliliters, so not liters. All right, so that answer would be A. Okay, milliliters are smaller than liters. There are 1,000 milliliters in 1 liter. So, and then at the grocery store, my dad told me that a gallon of milk is about 4 liters. About how many liters of milk would there be in 3 gallons? Okay, well, I'm going to multiply here. Okay. If there are 4 liters for 1 gallon and there are 3 gallons, all you have to do here is multiply 4 times 3, and that's going to be 12. Okay, so 4 liters times 3 equals 12 gallons. Okay. And we want to make sure we highlight our numbers. So let's see. Let's put a box here. Okay. The 4. We know the milk, a gallon of milk is 4 liters. And then about how many liters of milk would there be in 3 gallons? Okay. The answer would be 12. Let's draw a box here. Okay, and let's make it red, and let's darken the line. Okay. All right, so I'm going to stop sharing. That's the end of that number corner for today.